My topic today is just how to think about the concept of unique hues in human color vision. Specifically, should there be considered to be 4, 6, or 7 unique hues? As we know, Newton's original work identified 7 distinct hues in the rainbow, whereas the predominant choice of current color theory is 4 unique hues, following the 4 extrema of Hering's opponent color theory. The CIE space, on the other hand, is based on the concept of a triangle of 3 primaries, red, green, and blue. Thus, the 2 pairs of opponent colors, red, green, and blue, yellow, are the basis for the idea that these 4 colors may be considered the unique hues or characteristic colors of which all other colors are combinations. It has been espoused by a broad range of authorities in the field, such as those listed here. This coding is brought into question by the complementary colors of the CMYK system and of color afterimages, in which each corner of the triangular red-green-blue color space has a distinct complementary color of cyan, magenta, and yellow respectively, forming a secondary set of unique hues. This concept was supported by a neurophysiological reanalysis of color opponency by Ralph Pridmore in 2013. Note that, as the black line shows, red and green are a long way from being a complementary pair in the CIE space. A key issue, therefore, is whether afterimages form opponent pairings or complementary pairings. To discriminate between these two hypotheses, we ran afterimage studies for the 6 primary and secondary colors spanning the color space. Here they are at maximum luminance, all looking notably different from each other. However, for a clean test, they need to be set to equiluminance, which means equal to the blue, the dimmest of the 6. So, please stare at the round dot for 10 seconds to build up the afterimage, and do not move your eyes as I change the slide. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Keep fixating as you allow your attention to view the colors on the left. Now adapt again and keep fixating on the round dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now here's a direct comparison between the afterimage colors and the real comparison colors on the right. The realizable color gamut makes it clear that the available cyan strength predicts a much weaker red afterimage than the available red image, as found in the data. Afterimage matches for 2 observers, shown by the head of each arrow relative to the tail, show that the afterimages are complementary through the empirical white point and do not support the operation of red-green opponency. Evidence for the 6 unique hue concept comes from increasing the contrast of the color circle. While the regular color circle has 3 predominant primary colors, increasing the contrast brings in 3 secondary colors of equal perceptual distinctness. Additional evidence comes from the study of Berger, Atkinson, and Cropper for the loci of 4 unique hues in the Darrington-Krauskopf and Lenny opponent color space, which is a linear transformation of cone response space. Notice that the new unique hues lay out in more of a peace sign than a cross shape, leaving an open space for 2 more candidates for the unique hues, just like the color circle. So here are my conclusions. I don't really have time to read them all, so I'll just leave them up here for you to contemplate. Thanks all for your attention.